finishing up on the trig that now involves with everything else also the double angles and compound angles. Because if I say solve for x, I'm busy with a what sum? Solving trigonometric equations, a KEZ sum. This particular one is not just a general solution, it's a specific solution, because I want the x to only lie between minus 180 and plus 180. So if I have a look at the sum, how is this not a grade 11 sum? Because you didn't do this last year. You didn't know anything about double angles. So obviously you've got to do something with the sin, which is going to be 2 sin x cos x, and everybody should get that one mark. Please be quiet. And then we've got minus sin x cos x plus 1 equal to 0, and we've got a sin squared. Now, problem. What type of a KEZ sum do you think this is going to be?
Isn't the last chapter?
There's so many terms, I think that type 4 is the obvious choice. But then type 4 means that you've got to factorize. Now factorize this. Now first of all, you can simplify a little bit. You can simplify because these two terms are like terms. So you're going to get minus 3 sin x cos x. But the sin square, let me write it first, and the plus 1 almost lets me think I'm busy with that.
Identity.
Quadratic trinomial. But why is this not lekker? A quadratic trinomial is either going to be something, say, let's say a squared minus 2a plus 1, whatever. Or it could sometimes be whatever. I'm not giving you stuff that can factorize now. But if it's only one variable, it's got to be something like that. If there's two variables, something in the vicinity of this. Why am I saying that? Look at the middle term. How many variables have you got? You've got sin x variable and cos x variable. It's like AB. And here I've got the a squared, so I'm short something there to make it a proper quadratic trinomial. So if you want to do it, you can't. So now what? Now, problem with the sum. You can't do it. What do you need? What do you need? What do you need at the back? A cos square. So how is it just going to appear? How is it just going to appear? Because 1 is sin squared plus cos squared. Isn't sin squared plus 1 something?
No.
No, it's not. If you were thinking sin squared plus cos squared is 1, that's right. But sin squared plus 1 is nothing. Sin squared minus 1 would then be minus cos squared, etc. You'll take your identity and you'll manipulate sin squared plus cos squared being 1. But this is not an identity, but I could make the 1 what? Sin squared
Plus cos squared.
sin squared plus cos squared. Is that helping? Well, it's not written correctly now at the moment. I've got to now simplify a little bit and get it all together. This being 2 sin squared. The minus 3 sin cos in the middle, and then plus the cos square I was shorting to get a proper quadratic trinomial. Our James Bond type of factorization. Now guys, if you are in the habit of working with your calculator, this was a little bit more difficult than just that. If you do go with your calculator, you must remember that the coefficients that you're getting is for having something in the front with sin, at the back with cos, because this is where we're aiming towards. But we don't know what those coefficients are. So if you went old school for this, because remember you can't work with a calculator if you're doing NBT tests, so you've got to still be able to do it old school. Old school being that the 2 is 1 times 2, and the 1 is 1 times 1. Cross multiplication is 2 and 1. How do I get to negative 3? Both of them must be minus. So then this means something in our James Bond undercover spy language, it means that the coefficients here should be 1 and minus, no, sorry, I'm on the wrong space. 1 and minus 1. And this should be 2 and minus 1. Those were our two brackets that we're going to be using for our factorization. We don't care how you do the factorization. If you do it with a calculator, without the calculator, with whichever technique you were taught, I don't care. That's your factorization. I've left too much space there, but anyway. So then the next step would be that sin x is equal to, remember, very important, if you've got two things multiplied and the answer is 0, I'm going back way back to grade 9 when you were taught. If two things are timed and the answer is 0, then one of them has to be 0. If it's anything else, if it was like equal to 1, you can't say one of them is 1. But if it's 0, one of them has to be 0. The only way that you can get a product equal to 0 is if one of them is 0. So either this is equal to 0, meaning that sin x is equal to cos x. You can write first 2 sin x minus cos x equals 0, and therefore sin x is equal to, let me write it like that, it's fine. You could have written it immediately as a half cos or whatever, but we're writing out our two possible answers. Or, very importantly, or. Don't lose it, leave it out, it's going to cost you more. Then, we said that this was type number 4, factorizing. What type is this? 2 or 3, we never can tell. It's the one where the angles are the same. So you do divide by cos. And if you divide by cos, you get to tan. Remember the rule. You're never supposed to divide by a variable. How can I then divide by cos? It's not there. Because that cos is still there. It's not gone. You're not dividing by it and it's gone. That cos is still there. Part of the tan. Are you with me? We always teach you never to divide by a variable. You've just done that. Why? Because it's not gone. It's still there. Same thing's going to happen on the other side. You're going to divide by cos, and you're going to get 2 tan equal to 1. And then you're going to go tan x is equal to a half, because now we are with type 1. KEZ sum. Where you've got sin or cos or tan equal to a number. Sin or cos or tan equal to a number. That's type number 1. For type number 1, you first get your what? Reference angle, and your reference angle for tan being 1 is 45. You know that off by heart because you know your sketches. Is 45. Then we always say, which quadrant are we? Tan is positive. So I am in which quadrant? 1 and 3. But then we always said, no, I don't have to write that as long as I write
K times 180.
Okay. Then in quadrant number 1, the angle's name, because it could have been something else than just x. It could have been 2x or whatever. X is equal to, in the first quadrant, it's just the reference angle plus the k times 1. 80, and to be complete, we say 6. Second one, what is the reference angle of tan being equal to a half, please? Because that's not
26,57.
26,57.
Yes.
Okay? And again, the same principle. Tan is positive, first and third quadrant. You're not going to write that one, we're just going to write quadrant 1. Angle's name is x. Reference angle was just 26,57. Remember, if it was quadrant 2, you'd write 180 minus. 3, you'd write 180 plus. 4, you'd write 360 minus, and don't forget your k times 180. Now, if you stop there, you haven't answered the question, because I'm asking you for a specific solution. So when you do the sum, please make a note for yourself, not to forget when you get here, they're actually asking you for the specific solution. Now, specific solution is worth another extra 1 more. If you do what? So your x has to be equal to, start off here, so far apart. Okay. First one that you would get is 45 degrees. Degree? Then you're going to add 180, but then that's going to be way bigger than 180, so I'm not going to do that. I'm just going to say minus with 180 and get minus 135, and if I minus another 180, it's going to be 2. small. So I'm done with that general one. Go to this general one, first answer, 26,57. Then when I add 180, it's too big. When I subtract, what's the answer please? -1. Help me here, I'm doing it out of my head, if it's correct. If this is correct, it should be 1 mark. 1 mark that you were losing if you didn't do all of it. Do you think they would have subtracted a mark from you for not writing KEZ? Maybe in this case not, because we're working with specific solutions, but still you had to use the K by saying add, and subtract. So don't forget your KEZ. All right. Okay, problem with this sum. There's the sum. You've got one term on the left, one term on the right. It kind of looks like the sin cos one. One sin on the one side, one cos on the other side. The angles are not the same, but there's the other problem. That negative there shouldn't be there. So what do I do with it?
You take it out?
Because it has to be plus. Divide by a negative, then it's there. And then? Okay, to which other side? Left and right, and left and right. You're not supposed to have it there. Whether it's the same angle or whether it's different angles, you cannot have a negative on one of the sides. It doesn't help, it doesn't work. Our technique for the same angle or different angles, it doesn't work unless they both are positive. Now, how would we make it positive?
Minus cos. Yes.
Okay, no, it's not going to help me. I've got to make the ratio positive. How do I make the ratio positive?
Make an angle.
Make the angle?
Negative.
Okay, you're on the right track. But it's not going to help me here. If I say, let's make the ratio positive and the angle negative, it's not working. Why? Because cos, if I take a negative angle and make it positive, it's not going to be negative. It's not a huge problem, and we did some of this last year, you just have forgotten. Okay? That can't work, but I can take it to the other side and say, well, let's make it minus sin. Is that still true? Okay, but that's what you said, but you were saying minus there, out here, there. The problem is, what do we do to get it away? We take the ratio and make the ratio positive, but make the angle. Do you all understand why I couldn't do it here?
Yes,
Because cos minus x is plus cos x. It didn't work here. I'm going to make the sum still be the same original sum. So there is a possibility of having a negative ratio, but then you've got to make the angle ratio negative so that the ratio will become positive. But you couldn't do it with cos, because cos is the one that we say make the angle positive and the ratio negative except for cos. All right. So now we can go on. How many marks for that? 1. It's a principle that they both should be positive. Now we've got the situation of sin and cos, but the angles are different. So what do we do then?
Make it a
Make them both cos. There's no other way, not according to my technique I've taught you. There are other ways, but not what I've taught you. So if I want to change the sin into cos, what's it going to become? 90 minus the x and the minus 30. If you write that, it's wrong. It's going to be minus the whole thing, which is going to be minus x and plus 30. Guys, if you can save yourself a step, then please do. So you can immediately say that. But don't get confused with the minuses. And even more than that, wasting a lot of time here, just for simplification, so that then, and this is the only type of the 4 KEZ types, that you do not go to your calculator and get a reference angle. What do you do now? You make a logical
deduction,
which is what? Okay, but that's not quite
Plus
right,
minus.
but you with me what we did. If cos is cos something else, the angles should be the same, but that's totally wrong because you're going to get get one answer here and you should be getting many. How do we get many?
Plus minus.
But can I not put the plus minus here?
Okay.
Yes, you can. And that would have been a better idea. But as you've been taught, maybe you like your rituals, and then also plus the, because now it's right. But without the plus minus, without the k times 360, it's wrong. So then we split them up and say it's x equal to 120 minus x plus k 360, or minus 120 plus x plus k 360. Are you with me here? If the minus is there, it's going to be minus and plus. Then we simplify. So this is going to be 2x. If we get the x solved on the left-hand side, 120 plus k 360, divide the whole thing by 2 is going to be 60 plus k times 1, 80. Done. General solution. Okay, KEZ still to be written. For this one, what's going to happen here? X and minus x is going to give me, where's the x? Gone. So what do we write when we get a sum that says something like, there's no solution for x here.
It's like a
With me?
separate.
Happening inside of Trig, things that you've been taught in algebra. But don't forget your pairs, and if I'm stopping here, I'm wrong. Because I still need to get my specific solution, which is x is any which one of. First of all, 60. Is 60 in the range that I can work? Yes. If I add 180, it's 240. Is that fine?
Yes.
If I add another 180, it's going to be too big. If you go 60 and minus 180, you're going to get minus 120. It's too small. You with me? So 60 plus 180 and 60 minus the 180. But all that work was 60 plus 180, that was 240. Plus another 180 is too big. And if you take 60 and you minus 180, it's going to be too small. So there was just two specific answers.